Hello. Today we're going to continue solving equations, but with a little twist. The directions here say solve the following equations if possible. So let's try this. First thing I see here are my parentheses, so I know I'm going to have to do the distributive property. So I have 3 times x, which is 3x, and don't forget to dance with the guy on the other side. 3 times 4 is 12. Now we learned when we had variables on both sides that we have to get rid of one of the variables. So we are I'm going to choose to get rid of this 3x. And here is where we run into a problem. 3x minus 3x is 0. That cancels out. So right now I have 0 equals 12. Is that possible? Will you ever have a time where 0 is equal to 12? The answer is no. So what we're going to be learning about today are equations that have different types of solutions other than just one solution, x equals a number. So really there are 3 types of situations when solving equations. For most equations, it's like what we've been working with. When you solve the equation, you have the variable on one side and a number on the other. This type of equation, so the variable on one side, the number on the other side, like these examples, has one solution. The solution is the number that the variable represents. However, there are going to be times, like with the example we just did, that when you solve the equation, you're going to end up with a number on one side, a number on the other side, and the numbers do not equal each other. Like 45 does not equal negative 100. 3 does not equal 9. 10 does not equal 8, for example. When this occurs, when the variables disappear and you're left with 2 numbers that are not equal to each other, it can never happen. So we say that this type of equation has no solution. It will never work. We cannot ever find a number that when we plug it in for the variable, it comes out to be a true statement. So it has no solutions. And the third type of equation, the variables disappear like they did for the second type, but when you simplify, you end up with a number on one side that does equal the number on the other side, like 45 equals 45, 19 equals 19, 3 equals 3. So if the numbers equal each other, that means no matter what we put in for x, it will make a true statement. So we say these equations have an infinitely many solutions. No matter what we put in for x, it will make a true statement. So we can either have one solution, no solutions, or many solutions. So from now on, when you are solving equations, you're going to have to decide at the end what the solution is. So let's take a look at some examples. So for example, this one, 2 equals 2. We are left with a number equal to another number. So that means that no matter what we put in for our variable, it's going to make a true statement. So if you end up with an answer where the 2 numbers are equal to each other, it's many solutions. What about this one? X equals 7. X equals 7, that's telling us that no matter what, x, or the variable, equals 7. So we only have one solution. Negative 15 equals negative 15. If you end up, after you solve the equations, if you end up with a solution like this, it means there are many solutions, that no matter what, it's going to work out. 25 equals 52. 25 will never equal 52. So that's a no solution. There's nothing we could put in for x that would make a true statement. Oh, here's another x equals 7. X equals 7, one solution. X will always be 7 for that equation. 5 equals negative 5. No matter what, 5 will not equal negative 5. The 5's look the same, but remember 1 is positive and 1 is negative. So no matter what we put in for x, we will not get a true statement. Let's see what we have left. 3 equals 3. No matter what we put in for x, it will make a true statement. So again, if we end up with a number equal to that number and they are the same number, it's many solutions. X equals negative 9. No matter what, x is negative 9, so that's one solution. The solution is negative 9. x equals 4, one solution. No matter what, x is 4. And 10 equals 8. The two numbers, 10 will never equal 8, so that's a no solution. No matter what we put in for the variable, it will not make a true statement. So let's try some examples. So first, I'm going to separate my sides and see if there's anything I can combine. Well, here I see x plus x. They're like terms that can be simplified to 2x. Plus 8 on this side, and I'm just going to rewrite the other side, 2x plus 7. I see that I have variables on both sides, so if I have variables on both sides, I need to get rid of one of the sides, one of the variables. So I'm going to get rid of the right side, 2x. I'm going to subtract over here, 2x. 2x minus 2x, that cancels. I'm left with 7 here. 2x minus 2x, that cancels. I'm left with 8 here. 7 equals 8. That does not make a true statement. 7 will never equal 8. So we say this equation has no solution. Or we can say none. No matter what we put in for x, it will never make a true statement. All right, let's try another. I see parentheses, so I know that I have to do the distributive property. 6 times x, we're going to write as 6x. 6 times 2 is 12. This is a subtraction, so we're going to have it as a subtraction there. And we're going to just rewrite the other side. I see variables on both sides, so I'm going to get rid of one of them. I'm going to subtract 6x. Now I'm left with 6x minus 6x. It cancels, so I'm left with negative 12 over here. 6x minus 6x cancels. I'm left with negative 12 over here. Negative 12 does equal negative 12. What this tells me is that no matter what I put in for the variable, it is going to make a true statement. I can see even right here that the two sides are identical. That means no matter what I put in, 0, negative 10, 100, well, no matter what I put in, they're going to be equal to each other. So we simply say this equation has many solutions. Now remember, most of your equations are still going to simplify or solve all the way down to x equals a number, in which case this would be your one solution. So those are the different types you're going to be looking for. No solutions, where you simplify it down, you solve it, and the two numbers don't equal each other. Many solutions where there's not a variable left at the end and the numbers do equal each other. And the one you see most often, a variable equal to a number, so this is your one solution, that number. Thanks.